Yeah, hi. My name is Akhilesh Nair, and I'm a master's in computer science student at UIC. And today I'll be demonstrating a project that I've done recently as a part of the course CS441 Engineering Distributed Objects for Cloud Computing, taught by Professor Dr. Mark Grechanik. So, in the previous video, we had designed an encoder for a large language model, and in that, we had used Hadoop. In this particular project, we are using Apache Spark and DL4J, and the system will employ the long short-term memory layer and positional embeddings to predict subsequent token embeddings based on the input sequences. And the distributed computing is handled by AWS EMR as in previously. Uh, Project overview. So in the previous homework we had the output was the token embeddings, right? And in this particular uh, part of the project, we will be utilizing the token sequences to generate the overlapping sliding windows. And also, we'll be enhancing the token embeddings by calculating the position encoding embeddings for each element in the sliding window that is coming from the previous part. And the structure of the data would be in pairs, like the input and the target embedding datasets. And the we'll be training the model using a neural network model that is provided by deep learning 4J. And we will passing the input and target embedding datasets to it. So I have divided the project into two parts. Basically, the first one is to calculate the sliding windows and to form a pair of the input and the target embeddings. So as you can see here, I have placed the took embeddings and the ordered output from the previous project in this particular file. Although this is in the local directory, I'll be showing you on EMR as in how to do it over there. So yeah, the so we'll be loading the tokens and creating the sliding windows. You can go over the code later on if you want to. And the output would be the uh, input and target embedding pair, right? And we'll be storing it in a particular folder. So let's go to the EMR, and I'll be adding a step here. Let's name it the first, or basically sliding window. Mhm. And I've already let me show you the buckets as well. So in the bucket I have the jar placed in the jar folder, and the input I have the embeddings.csv and output.csv that I've shown you earlier as well, right? So we'll be selecting the jar from here, and the commands I've already written, so I'll be copy pasting them. Yeah, sorry. Yeah, so basically we'll be running this particular class which contains the code for that, and we'll be passing in the arguments. First is the location from where it has to pick up the files. This is the location of the embeddings, and this is the location of the output.csv. And this will be our location. We can change it for now. I'll say trained data output. All right, and I'm going to run it, and I'll come back when it is done. Yeah, so as you can see, the job has been completed, and I can show you the output folder in the HDFS. This is in the train data output, So for visual purposes, I have uh, like compiled into two parts, basically the CSV as well as the normal output, that is the HDFS output. So we can go over here in the object, and this is our output. This contains the input and target pairs. Um, so this will be fed as the input for the next job, and can go over to the code as well. Yeah, so we'll be picking up the training data and we'll be placing it in the RDD, that is the data structure used in Spark basically. And yeah, then we'll be computing the target embeddings. We'll be splitting the data into target and validation sets, and then we define the neural network configuration that we had discussed earlier as well. We initialize the network and then basically train the model based on the number of epochs you have set. Currently it is set to 5, and then we'll be calculating the stats, the loss functions, the accuracy, and various other stats. We'll be going through that later on. So let's create the job for the next program. So I'm going to name it as training model, and we'll be using the same jar. All right, and the function, the class will be this one, and the location will be using the, so basically this one contains the input, right? Oops. And obviously the part 00 files, and the output we can set it as whatever you want. So I'm going to copy paste this one. So I'm going to say it trained model output. This will show the stats, and this will contain the model. All right, we're good to go. So I'll come back when it is finished. Yeah, so as we can see, the second job also has been finished, and the output can be found here, the trained model output, and we have the model.zip and the stats.txt. So I'm going to download the stats.txt and show it to you. Yeah, so I've downloaded, I've copied the file from HDFS to S3. For some reason, I was not able to download from HDFS. So yeah, so let me just download it. Yeah, so as you can see, this is the stats. Mention the start time and time, the total duration, the number of epochs. Since you have mentioned 5 epochs, this will show the statistics for each epoch, the time for each, the duration, memory usage, the loss functions, and the Spark metrics. Yeah, can go through this later on as well. I'll attach it to the GitHub repository. Yeah, so this was the scope of this particular project, and so going forward, we'll be using utilizing the zip model.zip that we had created uh, for generating text now. So that will be in the third phase, and we'll be utilizing Amazon Bedrock that is designed to handle client requests via cloud deployed AWS Lambda functions. So that's it for this project, and I'll see you in the next one. Thank you.